We already know if you want to transfer your information from the transmitter to the receiver, okay? So these are the process that you take, okay? So for example, if you want to send a video, okay, or an image, okay, so what is going to happen is when you send that image, you need first to encode the image, okay? Then you go to the channel encoder, modulator, and then you send it to the electromagnetic or you send it to the wireless channel. Okay, so now what we'll be discussing, you're going to see what happened when we cover this encoder, what's happening inside the encoder, okay, or decoder. Decoder is just the inverse operation of the encoder. So let's get right into it so then we can see what is encoder and what are the process that is happening inside the encoder. Okay, it's just a way to convert our analog signal. Remember, this is the analog signal, and then this is where you're gonna get a digital signal at the output. So you're gonna get a digital signal here, then you're going to enter with an analog signal. So the encoder does the ADC conversion. Okay, so now we're going to see what is happening inside that ADC conversion. Okay, so that's what we'll be covering now. So it says like the analog to digital conversion, we start with sampling, quantization, and encoding. So we're going to see what's going to be what is the representation of sampling, quantization, and encoder, or maybe coder. So we're going just to give you an example where you can understand this principle. Okay, just to give you an idea, when we start with an analog signal, we're going to end up with a digital signal. Okay, so in such a way that we're going to start by sampling, and this is an example of our initial signal. We're going to take it to quantizations. Okay, after sampling, we take it to quantization, we get this signal, and from this signal we move to encoder. Okay, so then we can end up with the digital signal that you see here. Okay, and in simple terms, sampling makes the signal discrete in time, quantization makes discrete in amplitude, and encoder map the quantization value. Okay, as you can see here, I'm going to show you another image, and just to give you an idea, we're going to go with the pulse code modulation. This is the process that we are seeing now. We got 4 steps. Okay, first you got your analog signal, you go by filtering the signal, okay, then by sampling, quantizing, encoding, and then you're gonna get your digital output. So we're going to skip the filtering process. We're going to start with the sampling, quantization, and encoding. You can see that this is the initial signal, okay, and quantization is just the process of picking up after a certain interval where the signal is. Okay, that's what you see, the dot that you see, the presentation of the discrete point that you see there. Okay, and from encoding, we're going to represent this into binary format. So that's what you see, digital signal. So in such a way we can store the data or transfer the data. So we start with analog signal, then we end up with a digital. And in simple terms, this is just to give you an idea of sampling. Okay, so the input signal, here are the first type of input signal, and this is the sampling of that signal. You can see it's at each point we're going just to put the same interval and then represent this graph, and this is sampling of the first interval. Now this one with the initial graph, we're going to And this is for the second interval. We're going to sample this one, so we're going to represent each point. Okay, you can see it exactly as you see that side. We're going to represent with the same at the same interval. Okay, sampling interval. So then we're going to end up with this signal. And here is another signal. It's an analog signal, sound wave. Then we're going to represent it as a sampling signal. You see, like we're taking each point, okay, with the same interval, so then we can represent the signal. And in summary, this is the analog signal that we're going to start with, okay. And this is the PCM encoder process, this block that you see here, okay. And this is the digital output. This is where we start from ADC, from analog to digital conversion, okay, as the output. You can even see after sampling we have a palm signal, okay. So that's the signal that we call palm signal. It's after sampling, and then we're going quantizing the signal. So that's why we're gonna get something like this and encode the signal, so we can get the digital signal at the output. Okay, so now you can see from the analog to digital image. For example, you go to image, okay. Initially we have an image, then you take your image. We're going to we get the image as an analog signal. Then when we go to sampling is actually the representation of from each interval. Okay, we're going to represent this one in discrete mode at each interval. That's what we call sampling. Okay, you can see this is like an example of sampling a signal. Okay, and that's the representation you see here, the sampling process. And from the sampling process you go to quantization, and quantization is just gonna keep the amplitude point. Okay, so that's what you see, quantization here. So then we can get the digital image and represent it accordingly. So this is how we go from analog to digital conversion. Okay, just to emphasize what we just said, you can use analog to digital conversion to store information inside your PC, computers. Okay, we say that we use it to transfer information. You can also use it for you to store the information. Okay, so again, this is an example. You got your storage inside your computer. Okay, you have a physical signal. Okay, and it can be any type of you can have a sensor like a motion sensor. This is more like when you work with temperature, when you work with microcontrollers, for example. Okay, so the way that you take the information and then you store it on your PC as digital, for example. Okay, so you're gonna have a physical form. A transducer sensor, it's actually a sensor that allow you to convert analog to digital. This sensor that you see, transducer, okay, it's a widget to convert analog to digital. Okay, so to convert analog physical form, like you see, for example, if it's as a let me just give you an example. DHT, a temperature humidity sensor. We take the physical readings, we convert it into digital, so we're gonna get digital signal here. So, and all of this, it's happening after the transducer. So let's say just this block, it's actually represent connected. So it's like we go with a transducer, signal continuously, and a ADC converter. Then we're going to have to be able to store the information into the computer. Okay, so now you can see we have a discrete signal. It's an example of a discrete signal which is represented by 0 and 1. Okay, binary. And we have an example of an analog signal which we call continuously variable. So the signal is changing every time. And now we got our digital signal, which can be represented by 0 and 1 in different form. Okay. That's what you see here. Multiple discrete value. Okay. Now, this is a noise representation. It's actually a bad signal that we need to avoid. That's why we use filter to fix, to change this signal to make it look like this. So we could sometimes use filter. Okay. The filtering process allows us to convert this noise signal into a stable signal. Okay, so that will give you an idea. Let's zoom in. So this is an example of if you have to store a analog signal as a digital data on your computer. Okay, maybe you need to process this information from your computer. So these are physical inputs. Okay, so in short, this is what we just saw. You have a physical form, so we're going to convert this analog signal into digital, so then we can store it inside your PC, a PC storage, for example, or we can process the data. So now, this is what you see. You have a physical system, transducer sensor. Okay, so that's going to convert the analog signal. So it's going to sense the analog signal. We go to continuous condition, and we have an analog digital converter. Then we end up with digital signal at the output. So this is like another way of converting analog to digital signal using sensors and physical sensor, like what you see here. It can be temperature sensor. Okay, for example, and this is the original signal. This is the analog sound wave, and this one is the digital sound wave, just to give you an idea. And this is, for example, a voice. You speak at the mic. You have like someone speaking to the mic, the voice, and then we convert the analog sound wave into digital. This is like an example, so it can be stored on your PC as digital, or maybe we can use this information, transfer it, so then at the output we can have another DAC so we can have a DAC converter, and a DAC is just the inverse of ADC, analog to digital converter. This one is digital to an analog converter. So we can do the opposite operation, so then we can obtain those analog waves and output them at a speaker. And where we need analog to digital, ADC or DAC, it's here when we work with multimedia content, video, email, photos, text, and so on. That's when we need to perform this analog to digital conversion, because if you want to store the information. Okay, and when we work with radio, TV, phones, PCs, okay, and we need to, this information that you see like text, for example, when you use your keyboard, you type your information, so your information, for you to send it, you do it manually. So there's interaction with the hardware and software, and this is a music and an example of multimedia that we have. Okay, this is multimedia. You can see text, audio, images, animation, video, interactive. These are the options that we have when we work with multimedia content. So that's why we need analog to digital conversion, for example, in the media field. So we can store what is physical into our digital storage, and we can process or transfer the information